I start with the next speaker, my first surgical experience on cadaver about 10 years ago, I think, in Izmir in Turkey, and then we moved to Ankara. He's one of the pioneers of surgical training on cadaver. Now he's moved towards other technology advancement, augmented reality and virtual reality, and now he's the founder of the Med3 Sim project. It's a pleasure to introduce you Emre Huri from Ankara.
Thank you so much, Roberto. It's really great pleasure to be with you again. And when you look at the picture now, it seems like a complex situation. Is Med3 3D maximum reality? No. Today I'm going to talk about how we should think as a basic matter if we are talking about the surgical training for our students, for our residents. And this is my practical daily life. Every time I use GoPro camera to teach my resident and to teach myself, because I am sometimes, time to time, I'm not only the trainer, but always I should be the student to think about that. So, when you look at that, the surgical training should be followed to technology, and we should follow the technology. And the technological instruments in urology and beyond urology, we are using every time. But now, the main philosophy of the technological tools is the innovation. And I like these sentences came from the Bill Gates notes. And innovations starts with the governments, not only you and this podium, and it supports for the creating the research and labs and universities, and for what? For changing the world. If we aim to change the world, we know that now this is the best way for technological improvement. We should collaborate with industry, and the university and industry collaboration is crucial for this aim. However, we know that we are working, teaching the students. And let's take a look at the OECD report for this, the student role on technological improvement. And you can see the creation of the startup. And maybe more than 10% goes to the students in Canada, Brazil, and Australia. And this is important for that. And now we have to motivate more young generation. However, if the young generation is not among the medical students, wants to be a physician for the future, and just they should know that they should follow these items and to become a team worker, and become a leader, and scientific, and plus for maybe for 10 years later, they should think about with the business and economy and the engineering. And this is the future of the physician. However, this is the history of the Med3 3D Muslim and the history of the creation of the 0 to 1. If you start the research, you are stand on 0 point, and you should point as a 1 if you want to achieve. You can achieve or not. You can success or fail, and I would like to introduce the first research-based European hub for medical 3D modeling, and this is granted by the European Union, Erasmus Plus, strategic partnership project, and with 5 countries and universities supports, and it lasts 2 years. However, we know that these the projects, and when you think about the urology beyond, standardization is another important issue. That is the main authority, IEEE EMBS working group, to make the standards for the worldwide as a 3D medical printing or the 3D simulation. This is the story of the students or the trainers and the virtuality, from virtual to reality, and the curiosity, innovation, enthusiasm, and the future, and the collaboration for how they will proceed to make the 3D modeling and reality. However, we are talking about the technology for training, for surgical training, and now we know that the transforming health simulation to medicine is important for us to manage the future in urology, and we know that the urology is close to new era, especially for implementation to the daily urological practice, as I mentioned. First of all, we know that the terminology is important. What is the reality? What is the virtuality? We are the reality, but if we will add some virtual elements onto the real environment, it's the augmented reality. You can see the milligrams reality, virtuality effect, and on each type of the reality and the virtuality can be used for surgical training. However, it depends on your skills, it depends on your team. This is one of the samples, the augmented reality and the virtual reality, virtual environment to teach the patient and to teach the physician during the examination, one of the orthopedic surgeon. However, this is another sample that's related to also our project, and you can do the surgery with using the glasses, VR glasses, and this is the type of the VR surgery. Another type of this is the AR surgery. However, we listened too much today. It was a very good presentation, and then we can use also some navigation system with AR-based navigation system in our daily practical life for retrograde internal surgery. And with the AR composition, it's still going on. We are still going on in working that, and maybe it will help us to decrease the time and to increase the efficacy, but not only for the patient care, but also the surgical training. And this is important. That's why I want to mention it. This is another important sample for you can use the anatomy training with using the augmented reality. I would like to stress that, first of all, you should know that this is the two-dimensional view. And converting two-dimensional to three-dimensional is not so difficult. So first of all, we should know how we will manage the two-dimensional view to three-dimensional view. However, we know that these are the best 3D models in my personal life at 8 years. And we can especially state that. Now, apart from the cataract section for surgical training, the feature is the 3D printing and the 3D simulation. If we use the organ models, and this is the important rule, we should need the BioCAD, a computer-aided design. By the way, we can create virtual models, and for 3D printing and for 3D simulation, and this is the flow chart from the CT or MRI scan to how we will make a medical printing at the end of the day. This is the main issue and the main goal of the project. This is a sample related to 3D modeling of the kidney. Actually, I would like to say it is a little bit different, the 3D modeling of the soft tissue than the hard tissue, like a bone. Why? Because there is a really complex anatomy, and you should know the anatomy, but as a neurologist or a medical student or a physician, you should firstly know each anatomical organ anatomy. And so you can see the two-dimensional segmentation, a three-dimensional segmentation, coloring, texturing, and creating the organ as a virtual organ. It depends on you. If you will use it for training, you can use also virtual type, but you can print as well if you want to do it. And this is a slide that shows us the virtual 3D urinary system. This is from the created patient-specific data, and you can see how the smooth layer of the organs from kidney to urethra, and then this is the same virtual model to physical model. And then, if we want to do any research, we know that we should have a fail. This is the failure of the project, but we did what I would like to stress that these models are not suitable for training because this is the experimental surgery session, and for this reason we changed our direction to how we can manage the new and the effective models for training, especially for flexible ureteroendoscopy. And then you can see the coloring and the material that we used for the surgery, and the movement of the flexible ureteroendoscopy inside the kidney help us a really good management for the organ model. And we know that that's right, and now that we can go forward. And after completion of all models, this is the URC, the 3D printed T-box models. These are research-based products. And these T boxes are our body. Within the body you can see the 3D printed models, and 5 models are here. And then we checked, and we had a training more than 500 students, urologists and residents. And then just take a look. Evaluation by trainee and the trainers completed during the session. But it's important to see how it has an efficacy during the training session. However, this is another important, in my opinion, for the TURP bipolar resection. And then, actually, if you want to make something for reality, augmented reality, or 3D printed model, you should know some technological tools and your borders. And this is the reverse engineering products of the bladder and the prostate. And then we use the chicken breast for making the bipolar TURP as an anatomical fashion using the novel technologies. However, on the other hand, as I mentioned in my previous sentences, if you have a virtual model, you can print it. And you can not, if you don't want to print it, you can use for the virtual reality. Just take a look at this picture. Can you imagine how they are looking at the laptop, what I am doing during this time? This is the curiosity, and now I will show you some examples from the Huri VR simulators. If you are interested in to do a retrograde internal surgery, and then you can use the leap motion technology. And first of all, we are evaluating the scoring system and the anatomical and the duration time. This is like a game-based training. And now you will see, and the student goes directly into the urethra after going into the bladder. And he saw the stone. When he broke the stone, you see, he got a 50 point, okay? And the duration, and we evaluated the session. This is another type of the simulator. As I mentioned, please, basically, this is the basic cystoscopy for our residents. Everybody can say that cystoscopy is no need, but I think it needs to learn about the more, how they will manage the facility. And this is another VR simulator cystoscopy model that can be evaluated by the trainer. This is the third story of the Huri VR simulator. We aimed especially for anatomic, step-by-step surgical procedures for nephrectomy. For example, you see here, we are clipping the artery, and then we are clipping the vein. But if you go directly to the renal vein, it's forbidden, and it's impossible to cut firstly the renal vein before the artery. So it is something step-by-step surgical procedures that we work on that. This is another, I would like to share another important type of project. You will see here the 3-dimensional abdominal aorta and the branch patient-specific data harvested and created by the real CT angiography. And when you look at this abdominal aorta, it's a patient-specific data. We aimed to teach the residents or the students to select an aorta branch and to go directly anatomically to branch of the abdominal aorta. As you remember, it's something complex. And then you can see this is the keyboard, like a game-based training, which is the one of the production of the Metro in 3D motion. And then you can measure the time, and then you can see how he is doing the right way on anatomical situation or not. And it is important for us because this project is not only the urology, anatomy and the surgery, but we aim to make an exploration, especially of renal calcium system using the patient-specific 3D data. Probably this will enhance the training before the surgery and the surgical planning as well. However, I talked a lot about the Metro in 3D modeling, but these are the part of the project. But actually, the project has a value if we can disseminate it as a worldwide. And this is our last multiplier event, the more than 600 participation we achieved, and totally more than 1,000 students educated during these 3D models. And I hopefully you are interested in the virtual real world after my talk. And if you are interested in that, you can make your own, dream, analyze, and create your team, and I think action. But if you want to join us, you are welcome to link this link. And this is the completely university-based project. And we created totally 12 different stations for students, not only the urologists, not only the surgeons, to how to deal with the new surgical training policy. I would like to thank you. This is our last photo from our last congress in Antioch, in Hatay, and the closure of the project. We will see how we will proceed the new augmented reality and the 3D medical printing for the future plan. Thank you so much.